Hello everyone, so in this video let us talk about the first three problems from the latest Lead Code Weekly Contest 312. So let's start. The first problem is pretty simple. It says that you have to sort the people. So you're given an array of strings, names, as well as an array of heights. So you're given like this, and that consists of different positive integers. So you're given some person name as well as their heights, and all of them are different integers. Now both the arrays are of length n, obviously. So what you have to do is that return the names in the descending order by the people height. Okay, so you have to sort them by the heights, and it's very simple. So what you can do is that you can club out these names and height into one pair inside a vector and just sort by their heights, and just after sorting in a descending order, whatever is the new name orders, you just print it out. So it's very much simple. You just have to do the sorting algorithm. So what we'll do is that we have created a vector or an array, you can say, of pairs of integers of length n. So we have to sort it by the height. So we'll first put heights, and the second one is names. So it is a pair of integer and string. Then sort it directly by in the descending order. So it's r begin. If it's ascending order, it will be begin. It's r begin, reverse begin. So it like descending order. So after sorting in descending order, you have to just print out or just return an array of vector of strings of the name. So just iterate over all of these sorted, let's say, person names after sorted by their heights, and just insert their names inside the answer vector and just print out answer. That's overall a solution for the first problem. Pretty much simple as it is. Second problem is also very observational, nothing much complicated here as well. So you have to find out the longest subarray with maximum bitwise AND. Understand from the problem statement, like problem name as well, that you have to find out the longest subarray with maximum bitwise AND. Okay, so you are given an integer array, and you just have to find out what is the length of the longest subarray that has the maximum AND bitwise AND possible of all the elements inside the subarray. Now, what you can understand from AND operation is that AND will only occur when, like if you do an AND of two numbers, then if the same bit are on in both the numbers, then only the resultant bit of the AND of two numbers will be on. That is the AND operation. Okay, so if you have an AND operation of, let's say, because you want to maximize the value, let's say that you take the maximum value. Let's say I'll take 3. Okay, if I take 3 and if I AND it with a smaller number, let's say 2, then eventually some of my bits will get off. Okay, why? Because in the smaller number will be having like 0 in somewhere before, and it will turn off my bits. It will never happen that a number that is like, if you are doing an AND of two number and the number will be a larger number than both of the number. Why? Because let's say one number is like this, okay, and the next number is larger. Let's say there is 2 ones and there is like this. So if the number is larger, then this is zeros and it will be like cancel out. Everything will be cancelled out. This will be only 1. This is a smaller number. Now you might be thinking that, okay, if the larger number is such that these 2 digits are like this is set, and this is the same as this. So this is like 1, this is 0, this is 1, and this is 0. Then also this number is eventually the same. This number is same. This will be overshadowed by this number, and this number, if this is 0 here, so this will be 0. If this is 0, then this will become a smaller number. This will not be incremented. So if I do an AND of any number, then it will either it will remain same or it will be decreased. When it will remain same, it will remain same when we are doing an AND of the same number. If the number is, let's say, like this, and if I'm doing an AND of the same number, then it will remain the same number. So it means that if I want to somehow maximize a number, I want to find out the maximum number. Okay, if I find out the maximum number and if I do the AND of all those numbers that are same maximum number, then I will get the maximum AND only. So the thing is that I have to first find out the maximum number inside the whole array and just find out the largest contiguous segment of that maximum number. Because if I take that maximum segment and I'll do the AND of all the number will remain the same because it will not change because it's an AND operation, and we just get the maximum. So the overall thing is that you have to find out the maximum of all the numbers and just find out the largest continuous subarray that is consisting of that maximum number only. That's the overall solution for this particular problem. You can get it with a very simple intuition. So the thing is that we have got the maximum number by this of the whole array, and then what we'll do is that we have pushed a negative number, so that I'll tell you why we have pushed a negative number. So we have to find out the maximum contiguous segment of, let's say, the maximum number. So we'll iterate over this array. If the number is equal to maximum number, we'll increment my current number. So I'm, let's say, building a sub array. Okay, so if I'm the current number is equal to maximum number, I will build my current length of sub array. Current length will increment by 1. If it is not the current number I'm looking for, which means that the subarray might have terminated. So in that case, the maximum length of the subarray I might have get is the maximum of the maximum length, which is 0. Like the maximum can be 1 because I can take the maximum number as well, or the current subarray that I've been building on. Okay, and because now the subarray has stopped, it has terminated, so I'll make my current length equal to 0. And it's just that you have to find out a continuous segment of the same number. Okay, and you just print out that maximum number. Because I want to terminate at the very end, I have inserted a -1 so that it will always terminate because the negative number will not be as a part of this array, and it will always terminate at the particular. Okay, that's why I terminated, or else I have to like write one more if condition for the last subarray that is building. Okay, and just return the maximum then. That's it. That is the second problem. It's not too much difficult as well. We have already talked about these type of problems a lot in our channel, so you can check out the other videos. The last problem is a good problem. A lot of my subscribers have asked me to make this video, so it's just a little bit tricky. You have to just draw the example. It will become more clear to you. So the problem name is find all good indices. So you're given a zero index integer array nums, okay, of size n and a positive integer k. So you're given an integer array nums and integer k. So okay. So what you'll do is for all the indexes I in the range of k till n minus k. Okay, so from k till n minus k, like there's some range. You have to find out what all are good indices. Indices is called good if it satisfies these two conditions. The k elements that are just before the I are non-increasing. So k elements that are just before the I are non-increasing, and the k elements that are just after I are non-decreasing. Okay, so that is why it is having a gap of k on the left and gap k of k, like k on the right side. So I've just get those middle k elements, like apart from those k on the left and k on the right, just for all the middle elements. Just check that for all the k on the left hand side, all the k elements that are before the ith index are non-increasing order, and on the k on the left hand side are non-decreasing order. Just check it out and just print out all the indexes that are satisfying this condition. Now, always read the example so that it will become more clear to you. So let's take this example only. Okay, so let's say 2 1 1 1 3 4 1. So let's say 2 1 1 1. Okay, 3 ones and then 4 3 4 1. Okay, and k is equal to 2. So I have to leave the first two numbers. I'll start from, so this is my range of let's say 5, because two numbers I have to leave from the left hand side, two numbers from the right hand side. For every number, the two numbers on the left hand side and the two numbers on the right hand side. So on the two numbers on the left hand side should be non-increasing. So left non-increasing and right non-decreasing. Now, non-increasing means that, like, when I say non-increasing, it means that I like it should not be like linearly increasing. It can be like increasing or decrease, like stay same or decrease. Okay, so it is non-increasing, so it means that either it will remain same or it will decrease. So whether the numbers on the left hand side are decreasing of this, they are not decreasing. Okay, but what you'll see here is an example, they are telling that it is decreasing. Okay, so what they're talking about is, let's say for the index 2, there I have got the answer, because this number, that is this, the array is decreasing. This is not decreasing from the point of the array. This is not decreasing in this direction, but it's decreasing in this direction. Because what they're talking about is that for the ith number, if you take an subarray of size k on the left hand side of this particular I, then that subarray should be decreasing or remaining same. What's the point? So if I take, let's say, the index 2 that is starting from this point, the array of size 2 on the left hand side is this 2 1. This is, like, you can say, like decreasing, which is considering the fact like it is correct. Similarly, two numbers on the right hand side are increasing. So what they're trying to find out is that subarray on the left hand side and the subarray on the right hand side of length k, one should be increasing, like one should be decreasing and one should be increasing. Got it? And you just have to find out that. That's the overall thing. So it's pretty much simple. Now we have like talked about these type of problems a lot on our channel. So what we'll do is that we will just create some sort of a prefix, move from left to right and right to left, and try to get a pattern out of it, and just check that how many numbers. So let's say I want to find it for this. For if I move from left to right, I want to somehow find that these numbers should be decreasing. till any point how many decreasing numbers are there. Okay, so I have to find out how many decreasing numbers are there till any ith point. So let's say, okay, so what you can see that the number of decreasing number till this point is, let's say, 1. Number decreasing point till this one is also 2 because this is smaller, so this is completely decreasing. Till this is 1 only because this, if I see that this is also like equal, so this is 3 because till this point there are 3 decreasing numbers, decreasing or equal. Okay, so this is decreasing or equal, this is also equal, so this is 4. This is greater, so I'll start from 1 again. This is, so this is, let's say, increasing again, so it will start from again. This is decreasing, so it will see. Hope you get the point. So what we are trying to do is that I will compare this current number with the previous number because I want the decreasing or equal numbers. If it is decreasing, I will just increment the previous value plus 1. And if it is decreasing or equal, I'll just create previous value plus 1. If it is not decreasing plus 1, I'll just initialize with 1 again because it's a new number in the pattern that we are talking about. Okay, so this is decreasing. But for the right hand side, let's say for this part, I have to get an array that has to again decrease. Okay, so for the right hand side, what I'm talking about, that it should be a non-decrease, it should be an increasing number. So it should be like this, it should be an increasing number. So if I move from right to left, because I'm moving from left to right for building out this array, from right to left, if it is increasing from this I till this end, if I move from right to left, it should be decreasing only. Because I will be building a decreasing array from here as well. Because at any I, how many decreasing patterns should be there? Okay, so let's say that if I want to find out what is the total number of elements that are decreasing till this point, and from the right hand side, so I have to tell that, okay, this is the maximum, then this is smaller, 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 so it will be decreasing till this point. So eventually I will be finding out decreasing patterns from both the left and right side. Got it? And just for every I, we just check out that whether the I minus 1 and I plus 1 have at least k decreasing patterns on both the sides, and if it is find out, then the answer is correct, then the answer is no. Or else the answer is no. So that's the whole thing. So what we've done is that we have a left and right pattern. For the very first element, we have already one number that is already present, that irrespective of whatever pattern is, it's always correct. So answer is left of 0 is 1 and right of 0 last and minus 1 is 1. Starting on the second index, so it is I equal to 1. We'll check that whether the ith number is less than the I minus 1 because it's still like decreasing number. If it is decreasing, then we'll take the previous number plus 1, and if it is not, we'll just take the previous number and we'll initialize it 1 again. Okay. Similarly, moving from right as well, we'll again check that the ith number should be less than the I plus 1 number, which is again decreasing. So from left and right, both we are finding out decreasing patterns as well. And then for the middle numbers from k till n minus k, for every number, we'll just check that whether left of I minus 1 number should have at least k decreasing pattern, and on the right of I plus 1 should be having more than k plus like decreasing pattern, number that are in decreasing pattern. If they are possible, like satisfying the condition, I'll just push back the index in the answer vector and just print out answer. That's the overall logic and the code part for the third problem as well. If you still have any doubts, you can mention in the comment box of this particular problem. Thank you for watching the video till the end. I will see you in the next one. Coding, and bye.